All right. So I guess you're all here for the workshop for natHACKS. Today we'll be going over, the Python boilers and talking about what that is, what that means, and doing a interactive workshop, so to speak, with working with the boilers and using them to do processing of biosignal data. So with that, we can get into it. So my name is Zach Selk. I'm the COO at NeurAlbertaTech. And I guess a bit about my background. Then I'm a CS student. I graduated here from the U of A a year and change ago. And right now I'm a professional developer at a company called Callion doing satellite telecommunications, or at least I was, and I'm moving on to finances, but that's neither here nor there. So today what we'll be doing is going over the Python boilers, and this will be quite a bit of an interactive workshop. So what we'll be doing is we'll be starting off installing all the prerequisite software that is needed to run it. And then we're going to go over PyQt 6 and talk about that library and how that library functions, because it's a useful library to use. And then we'll do a walkthrough of some of the code to show you how it works. So to start off with, we're going to get things installing, because this can take a little bit of time, and so we should get that done earlier on. We'll need two pieces of software. We'll need Git. So that can be, if you don't have Git already or not familiar with Git, then GitHub Desktop is a nice piece of software to be able to work with Git repositories. And then we'll need some sort of a package for dealing with Python. So if you're on Windows, then Conda is a good solution and useful for getting Python as well as dependencies for Python. If you're on Mac OS or Linux or Unix systems, then usually Python is installed and you don't have to worry too much about Conda, and you can use things natively. So yeah, I'll give you a minute to get those installed, and then we'll proceed after all of that is downloaded and on. And if you run into any troubles, then let me know and I can help you out. Also, I'll try to monitor the chat for anybody who is online and answer as many questions as I can. Hey. So right now we're going through and installing some prerequisite software to get started with the workshop. So yeah, if you don't have Git or are not familiar with Git, then installing GitHub Desktop is useful. And if you don't have Python or Python environments installed on your machine, then Conda can be useful for getting that set up. Yes? Sorry, no, I guess, yeah, no, that should cause any issues. And let me know when you have both Python and Git set up on your machines, and then we'll move on. If you have Python set up, oh wait, no, VMs are part of Python. Never mind, ignore me. All right. Everything going well? All right, so for those of you who have Git installed, then the repository that we'll be working with is the natHACKS 2023 Python boiler repo. And that can be found at github.com/NeurAlbertaTech/natHACKS Python natHACKS 2023 Python boilers. Or you can go to github.com/NeurAlbertaTech and you'll see it. It'll be one of the top repos. Sorry, that is the wrong one. That link is not right. It's the natHACKS_2023 Python boilers. That is my bad. I should fix that link before I send off these slides.
Earlier, removing the 2023 brought me there.
Yeah, let's just go NeurAlbertaTech. Oh, boiler and not boilers. So many spelling mistakes. So you could get the zip file. It'd be better to clone it if you download, or if you have a Git client, or if you downloaded GitHub Desktop. That's the, it's not necessary, but it's good to get in the habit of starting to use tools like this because they'll become really useful come natHACKS. Any luck? Yeah, that's the one. So yeah, so you just want to clone it with that command if you have that, or if you don't, an installed GitHub Desktop. Hey, not too bad. Just getting everybody to install the software needed.
Came to show support. With the hardware? Or is it just for Python?
Both.
I want to see how this works.
Well, take a seat, pull out your laptop, and join along.
Do you have it ready on yours?
I do not yet. I have not tried it on this machine, so that'll be fun. Any luck getting it downloaded?
Well, I wasn't sure if I had this one or not, because like the requirements, I know how I wasn't sure about this.
So yeah, that's it's probably a bad requirement to have. Any Python version above, I think, 3.7 automatically has it bundled with the distribution.
Okay, so then do I just like copy this and
So with that, you'll just want to, let's see, I've never used this before. Filter repositories, clone from the internet, and then just throw in the URL. You'll probably just want to copy it from the browser, the URL in the browser.
oh, okay. So this one?
Yeah. There you go. And so that just pulls it down for you, and then you have it under whatever path that it sent it to. All right, everybody looking good? Perfect. So, with that, then, okay, so next we're going to be setting up something called a virtual environment. So with Python, because of how it is, then a lot of times you run into issues with conflicting libraries for different projects. So if you're working on one project and it requires version 2 of a library and you're working on another that requires version 3, then you run into issues with those, the different versions of those libraries. So because of that, then many people tend to use something called virtual environments to isolate the dependencies for a project so that your environment doesn't affect it as much and doesn't cause things to break as much. So for next, you'll want to cd into, or go to the terminal and cd into the path where you downloaded the repo. And for those of you on Windows, you'll probably want to use the Anaconda. If you download Anaconda, you'll probably want to use the Anaconda prompt. And those of you on macOS or other Unix distributions, then you'll just use the normal terminal. And then there's a few different ways to get the virtual environment set up. So there's a way to do it with Conda if you're using Conda. And there's also a way to do it with virtual env or venv, which comes with Python nowadays. So those of you who have downloaded Conda, then you'll probably want to use this second line here, the conda env create -n name and -f requirements.txt. So what these commands do is they will create this environment for you, and they'll also go through and download all the dependencies for them. If you don't have conda, the command that you'll be looking for will be python space -m space venv and then space the whatever you want to call it, the name of it. And then with Conda, once you have created the environment, then you'll have to activate the environment when you want to use that environment. And what activating an environment does is it switches over all of your environment paths to point to the dependencies that are used in this project or whatever project they're using. I guess just to contextualize it a little bit, for those of you who are not using Conda, it's struggling. So if you're not using Conda, then the command that you'll be looking for will be something like something like this, where you, oh, that's really small. Let's make that a little bit bigger. something like this where you're creating a virtual environment called .vm, and I already have one. So then once you have that, to activate a VM, then what you will do is source the name of the environment, bin, and then activate. Or if you're on Windows, it'll be the name of the environment /scripts/activate, I believe. So for Windows, it'll be something like I believe something like that. And it might not require the sourcing before it, because it'll be a .ps1 file, I believe. Is there anyone running into any issues with the virtual environments?
Just confused on how to activate it.
Ah, yes.
I tried on the $sign activate the first time, so I'm not sure.
You don't want, so with the $sign, that denotes the start of a command, and you usually don't type that.
Oh,
It's, yeah, it's a weird thing that coders do.
so just conda activated work?
And then the name of it, so VM, looks like is what you called it.
I think I called it something else. It was like,
Ah, yeah.
and that's
Could not find it, so it's likely called something else. Here, let's see, what did you use to create it? Looks like it failed to create the workshop env because of conflicts. That's unfortunate. Try using VM instead of conda. So that Python -m VM and then the name.
still here on PowerShell
Yeah.
or something like that. Cool.
It should still work all the same.
So, wait, the second line?
The first line, so Python -m VM, and then the name of the virtual environment that you want. So you can call that your workshop env. Perfect. And then to activate this one, you do something like the second line. And instead of .vm, it will be .workshopenv. I believe that's what it's called, but you can use tab to complete to see what files exist. So if you just go up here, we'll just go. Okay, that's not great. That's /scripts. Of course. And then activate .bat probably. Okay, yeah, and so you can tell when a virtual environment is activated by, in parentheses, it'll say the name of the environment on your, I forget what it's called, your command line though. So you can see right here, then when you have your virtual environment correctly activated, it'll have the name of it in parentheses on your prompt line. So is everybody else set up? Oh, all right. You don't want to. You don't need to use the Anaconda Navigator. That's I don't know what that's for. That's under something else. So you can use just the terminal because you're on macOS to do a lot of these commands. So just go into your search, which is command space, or that, yeah, and just search terminal. And then you can do it from there. So to get to the directory where you downloaded the files, then you'll use a command called cd. So you'll do cd and then the path to where it was at. Yeah, so I believe it went under your documents folder. So if you go cd documents and then net, yes. There we go. So now you're in the directory where the repo was downloaded. And so now you can run some of those commands. So because you're on macOS, it would probably be easier and better to run these commands here. Really, it's the first command there, the Python -m vm, and then the name of the virtual environment. Yeah, something like that. Oh, you don't need the percent sign. That's just a part of what my terminal looks like. Nice. And then, so right now you see you're at base, so we want to switch it over to the virtual environment. And then to do that, you'll type source space .vm /bin/activate, and then hit enter. And now you see you're in your .vm environment. All right, so once everybody's in their virtual environment, then you'll run the following command to install all of the dependencies. So you'll run pip install -r requirements.txt, and you'll have to make sure that you are in the natHACKS 2023 Python boilers repo. And so this will be a long command that downloads all of the requisite libraries to run the Python boilers. And this is my first time trying to get these going on here, so hopefully this works. And then, so while those are downloading, because that takes quite an amount of time, especially on the Wi-Fi here, we can start going over PyQt6. So what PyQt6 is a library that's based off of or a library called Qt, which is spelled Qt. And what PyQt is a Python version of that library. And what the library is for designing GUIs and just graphical user applications in a relatively easy fashion. And it's fairly popular, so it has a decent amount of documentation and help on online forums. So it's again, a general purpose framework for just making user interfaces, or graphical user interfaces rather. And how it works in a high level is you generally have one or several windows, but generally just one. And what you do is you create something called widgets to nest in your window. And those widgets can nest within each other. And the widgets represent graphical objects that you want to be able to represent. And then the window itself has an event loop that it will continue to run so that it can update and run different code to react to how the user interacts with the user interface. And what you can do is you can connect different types of events that the user might do to different bits of code to be able to do that, to be able to react like that. And we'll get into more details later on in the hands-on portion of the workshop and show you what these abstract concepts are and how they look in practice. But this is just for a high-level view of the terminology that PyQt uses and the rough structure that you'll design things with in PyQt. So as I said, widgets are graphical objects that you want to represent, and each widget has the ability to create events or consume events, depending on what you're trying to do. And what events are basic things like from the user clicked on a button and that would generate an event, like an on-click event. Or there's lots of other types of events that can be generated, like when a window is closed, that's an event, or when a timer goes off, if you want to set things to happen after a certain interval of time, that is also an event that can be triggered. And there's a lot of different things, a lot of different events that you can run, and there's a lot of different ways in which you can have the user interact with these interfaces. So you have things like input with text boxes, and you have dialog box options with buttons and check boxes and all sorts of things. It can be even where the mouse is and what the mouse is hovering over, for example. So it's PyQt is quite rich in these events, as it calls it, and being an event-driven framework where everything happens when an event happens, and it's reactive. So with that, we can start on the walkthrough. So we'll be mainly focusing on the oddball.py file in the repo, and we might get into the main menu.py if there's time, and yeah. So with that, and we are still downloading, so we're just going to hope that finishes in time. But for now, we can start looking at the code. So I'm going to open up the oddball task.py. So that's at the root of the repository. And this is what the top looks like. And we can go over the code in more detail now. I guess just to go back, did everybody's requirements download work? Or did you run into any issues? Oh, fun. So this is one of the funner parts about Python, where you run into version mismatches quite frequently. Requires Python version. Okay, so this is saying that it requires different Python versions. This requires higher than 3.7, but so one of these libraries requires something lower than Python 3.11, but you're running 3.11.6. Can we just quickly change that? Of course not. This was for TensorBoard. we do not need that for now. And so we'll just skip that. Oops. We'll see if that works.
This time we'll be apart.
We're able to run successfully. Oh, it's still going. Okay.
Are you guys also covering the fact that how to connect the Muse to the boilerplate?
No, we're going to be working with simulated data. This should theoretically work just out of the box with something like a Muse, but don't want to complicate the live demo too much.
I agree. I'm going to cover this in my other the workshop, which is during the NeurAlbertaTech.
Mhm.
I'll be covering this as well, so I need to make
Oh,
sure.
perfect.
Higher, that's it.
You also ran into an issue.
I
Look.
just missed it.
Oh, no, that's the. Oh, sorry. Yeah, you won't have that command. To open it on Mac OS, you can run. What would there be? Nano? This is a really basic one. I'm assuming you don't have a code editor or anything of the sort. So this should work fine for now to view. So this is a really basic code editor. In order to leave the code editor, you do Control-X. That's what the caret is Control. Or if you want to do these other things, but Control-X is how you leave. And then just the arrow keys work. Alternative. Yeah, no, that'll be fine.
Just wanted to know something.
Mhm.
Did you just use your last year's same boilerplate?
Yep.
Perfect. I have that.
Or it's slightly different.
Did you make some good changes? Good changes?
This whole file is new as of this morning. So it's maybe not necessarily good changes, but it's changes. Is that running better? Nice. Yeah, these take a lot, or I've noticed these downloading these dependencies have been really struggling on this Wi-Fi.
Is that your mouse?
Yes.
Nice. I think I have the same.
Oh, yeah. All right, so yeah, while things are downloading and people are figuring things out, we can start going through the code a little bit. So this is a normal Python file. I guess out of curiosity, how many of you have ever worked with Python before? 1, 2, 3, 4. Okay, sounds good. All right, so yeah. This is what a Python file looks like. I guess one thing that is, yeah. So the general structure of a Python file is typically this optional, what this is called as a shebang, which just says what or how you would run the file and allows you to execute the file natively. Then there's a doc string at the top that describes what the file is, what the purpose of the file is, and just gives a short description as a comment here. And then you typically will import all of the libraries that you need in the file, and then the code will be will follow. So here, then what we have is a oddball task. So to give a brief overview of what the oddball task is typically when you are doing experiments in psychology, then one of the types of experiments that you can do is something called an oddball task. And what that is that you will show a participant a certain stimulus multiple times. And every now and again, you'll show them an oddball stimulus. So what an oddball stimulus is just something that is different from the normal stimulus, and it happens fairly infrequently and randomly. So in this file, what we have is it will show a cross or a plus sign that is, I believe, green normally, and it'll flash a green cross sign, and every now and again it'll flash a red plus symbol. And so the red plus symbol will be the oddball, and the green will be the standard or normal stimulus. And we're still downloading, so I cannot show it to you yet. All right, but yeah, so we'll kind of start going through the code and how code looks like using PyAcute and BrainFlow. So the main part of this file is the oddball task class. So with the oddball task, then when we start up, there's a couple of things to note. So the first thing is with any object that you're working with in PyAcute, generally what you want to do is you want to inherit from QWidget, and that makes it so your object becomes a widget, like we were talking about earlier. So with the structure of PyAcute, you have a window, and inside your window you have one or many widgets. So right here, then, this oddball task is a widget. And one thing that is common amongst widgets is you generally pass in this parent variable, and that informs the widget where it lies in the hierarchy of many widgets. So that typically can just be none, unless if you're doing something special. And then, so what we're doing here is we are creating a window. We're setting the different parameters for the window. So we set the minimum size in which we want the window to look, as well as the title for the window. Just some nice little things to add. And then after we initialize those bits of data, we create something called a layout in PyAcute. So what a layout is it's a way to structure your widgets in a certain way. So right here, what we have is something called a QV box layout, which is a layout that stacks all of your widgets vertically. The QV stands for Qt vertical box layout. So if you had 10 widgets and you put them all into this QV box layout, what it would do is it would show each of them stacked vertically on top of one another. And it would be really nice if this would finish so I could show you, but it's still chugging away. Yes, so then once you do that, you can set the layout. So what we're doing here is we are setting both a red cross and creating both a red cross and a green cross, and the layout to be used for later. And then we can jump to the board setup. So for what the board is typically what we'll be doing is we'll be working with BCI hardware. And for this sample, then we're just going to be simulating a piece of hardware. So we're passing in this simulate object. But when you're working with actual hardware, then you'll be passing in different bits of, or different types of, for example, would be a board that you could use and pass in to, and what this will do is it will connect to the board and start retrieving data from it, so that when we're running our program, then we can collect biosignal data or brain data while the application is running. All right, so then once we set up the board, we create a little pop-up dialog, and that just lets the user interact with and say when they want the experiment to start. And if they don't want it to start, then it closes the application. And then we do these two other tasks of setting up loop variables and starting the task. So what those are is So when you're working with PyQt, it's a little bit different than normal. So because we're working with a graphical interface, then we don't want to stop anything while we're processing. We want everything to be done asynchronously. Anytime that we do anything, we have to treat it a little bit differently, especially when we're working with loops. So typically when you're working with loops, you can just use a normal for loop or while loop and everything is fine. But the side effect of using for and while loops is that while you're doing that, then nothing else can happen while the loop is running. So which is usually fine in programs, but when you're working with graphical interfaces, if you have your code just looping and doing something, then your graphical user interface can't update because it requires processing time in order to update and register and events that are happening. So because of that, what we're doing is we're setting up different loop variables to act like a for or while loop, but asynchronously, and that can be continuously called, but can run different bits of code between calls. So that's what we're doing here. So we just have an iteration variable saying that we're starting off at iteration 0, and we have a total of 20 iterations that we'll be running through. And then we also set the chance for an oddball to occur, an oddball stimulus to occur, which is 20%. And then we start the task. So what we're doing here is we're using timers in order to perform these, to show the user stimulus. So we have a couple of timers here. Each of these timers, what they do is once you start them, they will run, or they'll wait for a certain amount of time. So in this case, this one is 1,000 milliseconds, this one's 250 milliseconds, and this one's 10 milliseconds. So every second, for example, then this timer will time out. And when it does, because what we did is we connected it to a function here. So when it times out, it will run this function for us, and thus being able to accomplish running code asynchronously in a loop. So every second, it's going to run the show stimulus function for us. And what show stimulus does is it just randomly decides whether or not it's going to show the oddball stimulus, which is a red cross, or the normal stimulus, which is a green cross in our example. So we do some logic to check for our loop conditions. So we check to see if we have looped more than our total number of iterations that we want, and if so, then we want to stop and finish the looping. Otherwise, we increment the current iteration, so the current loop that we are running in, and we show the stimulus. And then after showing the stimulus, then we will hide the stimulus after to give a break between. And this is really not working. Let's try that again. Yeah. So I guess, is there any questions so far? All right. Your guys' dependencies downloaded yet, and was there any issues?
Just don't know how to activate the
Oh, yep. So did you do it with Conda or with VM? Okay. So with Conda, you'll want to do, what's the command? Let's look it up. You'll want to do the bottom command here, the conda env create -n name -f requirements.txt. And will that work? Somebody else was having troubles with that one, so let's make sure it is happy. The joys of trying to get things to work on all the operating systems and environments possible.
Yeah.
Looks like it's doing all right though. More problems.
It happened a second time. I did the same thing we did, like deleted it on
Yep.
Notepad. I was just wondering how many times can I delete things until stuff starts breaking down?
It depends. So the problem with this is TensorFlow. We're not using TensorFlow right now. What TensorFlow is for is ML, machine learning.
Oh.
And so in this demo, we're not. To actually fix this problem, what you'll need to do would be to run a different version of Python, because it keeps complaining about the Python version, which you can do with something called pyenv, which allows you to download multiple versions of Python and switch between them. So you might want to look into that and get it set up at some point. It's pretty nice to have and use, because you run into these issues all the time of this version of Python works and this one doesn't, because Python likes to break things a lot. But yeah, for now, you can delete anything that mentions TensorFlow, for example, because we won't be touching that at all.
Is it important for the hackathon?
Yes, it can be. So there's two primary libraries that are typically used, TensorFlow and PyTorch. There's a couple other ones, but those are the big ones. So depending on your team and what your team knows and is comfortable with or wants to learn, then it'll probably be either TensorFlow or PyTorch. And that's only if you do machine learning. There's things that you can do without machine learning too. Yes.
So for the previous version which I was using,
Yes.
for 2022 one, I was running the, I didn't run it. Just one second.
I'm getting a weird error. I'm getting an error.
Oh, fun. And that was with which command?
I was just installing the dependencies from requirements.txt.
With pip?
Yeah.
Interesting. Was this M1 or Intel?
M1. Is that why?
It might be. I think M1 has troubles with PyQt5.
Oh.
I'm running PyQt5.
Well, sometimes it does. At least I've seen.
This is what I was going because I'm trying to run the main window directly, main program directly.
Oh yeah. That might actually be a legitimate error in the code. I haven't run the main window in quite some time, or main menu in quite some time. Baseline window.
I have a weird placement of my enter key.
Oh boy.
And tilde.
Yeah, sorry for that.
It's all good.
My keyboard layout is a bit different.
So this, okay. Baseline window, and then I'll just cat it. So we're looking for baseline win. Yeah, I refactored and broke things. It's not called baseline win, it's called baseline window now. Okay, let's go here. TXT, and yeah, so it's useful to know roughly how PyQt works, but the purpose of the Python boilers is to provide a bunch of random, or not random, but different scripts that show you how to do certain things with different user interfaces and with BrainFlow too, so that you can just copy what's there and modify it as needed. So as long as you have a very high level understanding of these libraries and how they work, then it is then you're able to steal the code from this repo without too much trouble and adjust it to your own needs as long as it's something close. And if not, it's a decent starting place for your projects. So with that, and because mine is still trying to download stuff, the other bit of code that I wanted to go over is the BrainFlow code. So currently what we're doing in this script is we're grabbing an object called board from the board file. And this is handling our BrainFlow connection, or the connection to BrainFlow, which allows us to connect to different headsets. So right now this file supports the Muse, OpenBCI, EXGPIL, and GTech. What was GTech? I think that might have been the Unicorn. But I guess the Ganglion, Cyton Daisy, Muse 1 and S, or sorry, Muse 2 and Muse S, the XGPIL and the Unicorn, which I believe is all but one of our headsets that it supports. And so what it does under the hood is it uses a library called BrainFlow. And BrainFlow is a really great library that we utilize, that its primary purpose is to connect to and collect data from different BCI headsets. So they have a whole host of headsets that they support. I think they have like 40 or 50 different types or models of headsets in there that's supported by their library. And you don't have to know too much of how this works, but if you know how this board file works, it helps alleviate issues that you might run into. So one of the useful parts of this class, or the interface for this, is get new data, which will collect or show you all of the most recent data that was collected by the headset and thus collected by BrainFlow, and allows you to grab it and analyze it, as well as get data quantity, which allows you to get a certain amount of data. So if you only want a single data point or 10 data points, then you can collect that amount. And yeah. One thing to note about BrainFlow is it stores data in a interesting format. So what BrainFlow does is it works with arrays of data, because with headsets, then typically you have multiple channels as well as other types of sensors. So how BrainFlow handles that is it gives you an array of data and an array of mappings saying which bits of data are what. So for example, here we have this variable called EXG channels. What BrainFlow will do is it'll send you, say, an array of 32 different numbers. And it'll say the indexes 5 to, say, 15 are EEG channels, for example. And so you can look at that and you can infer that, okay, so Index 5 of this array is channel 0, index 6 is channel 1, and so on and so forth. And that's how the data is represented in BrainFlow. But I'm just kind of going over this in high level because I believe tomorrow's workshop will go over connecting to headsets and working with the data in a lot more detail. So this is just kind of giving you the gist of how it's formatted and how it works. But yeah, so again, the purpose of these Python boilers is to see bits of code that seem appropriate for what you're trying to do and steal them and use them in your projects. Yeah. And we are running into issues. And we're going to see if we can get this working on this machine. Apologies for that. I don't typically run this code on this machine, so didn't test it out in my infinite wisdom. Questions?
You did say that the boilerplate was handled all of the PCI access you have, except for one?
I believe so. And the one would be the Duino.
Okay.
It would be pretty easy to add on of like following what the other headsets look like because it's a simple. It would be a simple copy and paste and then changing a couple of things. But yeah, I believe the Duino is the only one that is not supported by that. Yes.
It's unable to import because
Uh,
it exists in the code, right? But it's just unable to import the specific.
Does it exist in the code? I thought it got replaced with baseline window.
I think so. I was looking at it. Wait, I have it open on this code. Yep.
Yeah, and that's the issue of like it's trying to use that instead of. Is this no?
It's already in
Oh.
search.
Oh, I'm just trying to find and replace.
Yeah, it's already open. That's why it won't work. Yeah.
Oh, I see. Place. Nope.
It's F. Command C and Command.
Wait, sorry, what?
Do you just want to look for this?
I just want to replace all instances.
Let's go with change. But that'll also change this.
Yeah.
Let's change with.
Okay, so it's just used there.
Yeah, let's replace this.
And then just baseline window, something like that.
That's it. 2 places.
Now it might run. Another downside about Python is refactoring is not nice. Oh, yeah, that's another one I refactored. Dang it. But yeah, so because of technical difficulties, I don't think I'll be able to run this, unfortunately. Yeah, questions? Yes. Yep.
Is it just like the pip installation here?
I believe so, yeah. I think you can install it with pip.
Do I install it in the virtual environment or outside?
Outside.
Outside.
Yeah.
Also, is there a script for deactivating as well as for activating, or is there a
There is. Wait. There's not. If you type exit, it should leave. Well, that. I guess that did. There might be a deactivate script in the same folder as activate. What would that be? Oh, I think it's no longer Arduino Mac. What is it? Arduino. Oh no, it is Arduino Mac. Probably that.
Alright. Import name from. So which one are we changing?
Ardmac on. Hey.
Wait. I think it was PYQ26.
It is. That was the hard code string.
Oh, it's hard coding. Okay. Let's try running a test one.
Awesome.
Works.
Do you have USB-C on this?
Yes.
Aha. Do you mind if I steal this and demo some things?
You can just switch to useful.
Sounds good. All right. So my laptop is not happy with things, but this laptop is all right with running things. Is it gonna? Yep. Perfect. Thank you.
Do you want to show them this or do you want to show them by running it?
Let's show them, I guess first show them the oddball. Okay, so this is the oddball task. This is the code that we were just going over. So what it does first is it launches a dialog. So this is what a dialog is. So it's a simple little pop-up window, usually with two buttons like a yes or no, okay, cancel, so on and so forth, and a little message. So this pauses the execution of things until the dialog is handled, which we say, okay, we want to start. And so this is what happens. So we have the stimulus flashing on the screen, where the green cross is the normal, and the red cross is the oddball. And in the background, we have the data that's collected. It's simulated data, so it's just random noise. But if you had a headset on, then this would be the data that would be coming from the headset. Yeah, so fairly simple script. And so that's kind of just shows if you're trying to make something similar to that, then what you would do is you would just steal all that code and tweak things as necessary to get it to run something else. So then another useful script that we have is the main menu. And I don't think we have menu.
I don't think
Oh,
it already exists if you just go up.
So the main menu is kind of a larger script a larger, more complicated script that hooks into a lot of the other subscripts. So it's kind of just a menu to launch other bits of code and see what they do and how they run. So for example, if we select the OpenBCI, Cyton Daisy, we want to simulate the data. Save it to a CSV file and whatnot. Then we can do a graph, and this would show us the time series plot from the EEG data, or EEG headset, so the EEG data. Again, this is just simulated because we're not actually connected to a headset, but if we had one hooked up, then this theoretically would be a little bit more noisy looking and showing brain data. Another thing that we can do is do an impedance check, but we can't simulate that. What an impedance check is and what impedance is it's a way to measure how well electrodes are connecting to the scalp. So usually before you do anything, you want to do an impedance check to make sure that there's not, that all the connections are good and there's no no connections that are loose and giving you bad data. What else can we do with this? We can do a baseline. No, we can't. There was an error in the background. Ignore that. And yeah, so this gives you tools to be able to connect to the hardware, hopefully fairly easily, and start working with the hardware right away. And then grabbing code that is run here in order to use it in your own projects. Any questions? Yes.
What would be the output if your electrodes aren't, they don't have good contact with your scalp? What would the output be?
I don't remember what the output on this one is, but generally with any given impedance check software, it'll give you a number between like 1 and 100 usually, where high numbers are bad, but it'll also have like colors, so it'll be like red if it's bad and green if it's good, generally speaking. And a lot of times they're mapped around a headset, so you'll see, say, if you're wearing a Muse, then you'll see like 4 different electrodes across the forehead, and so it'd be 1, 2, 3, 4 side by side. Yeah, I don't quite remember what we wrote for this tool and how that looks, but and there's also other tools depending on which headsets you are working with. Some have their own tools to do impedance checking and graphing. So, for example, if you have an OpenBCI headset, then they have a OpenBCI GUI that you can run, and it gives you a lot more fine-grained details about the OpenBCI and things like the impedance, which the term they use is railed, as well as other information that's useful before you start collecting data. Other questions? I guess another thing to highlight. So here we have a CSV file that we can enter, and what happens in this code is that we're able to save a session or brain data to a CSV file, and then later play back that CSV file in a simulated fashion of, it's not live data, but it's post-processing data. So that's very useful for when you collect data, you collect it and save it to a file, doing whatever task that you're doing, and then you can read it again and run it through your code multiple times as you're tweaking and running or tweaking things and developing out your program, which is super useful, so that you don't have to just have somebody always wearing a headset and always doing tasks and then like, oh no, we hit a bug, okay, let's change this. So yeah, the typical workflow would be to collect a bunch of data and then process it in post, and then maybe setting up so that you can process it live if you wanted to, but working with that post-processed data is very useful. All right, any other questions? I guess with that, we can probably call it there. Ending a little bit earlier than planned, but that's fine. Yeah. Thank you all for coming.